minus the radical. So for example, 3 over root 2. We have to times by the conjugate, which would be the denominator, which is root 2. And you times this by the numerator and the denominator. So times and times. And that would get you 3 root 2 over root 4. Since these are the same, they can times together equaling root 4. And then you have to simplify to 3 root 2 over 2. Okay, so now we're going to try a little bit more difficult one. So 3 over root 2 minus 3. So you are going to times by the bottom term, which is the denominator, but you are going to change the negative into a positive because we want to cancel out the middle terms because it's the conjugate. So you do that to the top and the bottom. And then you get 3 root 2 plus 9. Do 2, 3, going into these. You are going to divide, or times, by root 2, which gives you 3 root 2, and then you're going to times by 3, which gives you the 9. And then you get root 4 due to root 2 timesing root 2 plus 3 root 2. Then you get minus 3 root 2. And then you get minus 9. Due to these being different, but having the same numbers, having different signs but having the same numbers, they cancel out. Then you get 3 root 2 plus 9 over root 4 minus 9. So we know 4 is a perfect square. We root 4 into 2. So that becomes 2 and 2. And then you group it, so you get 2 minus 9, which equals 7. Negative 7. Due to the 9 being negative. So the answer is 3 root 2 plus 9 over negative 7.
So to review basic factoring, if we had something like 8y to the power of 5 plus 4y cubed plus, subtract 4y to the power of 4. So we bring out our highest common multiple for our coefficients, and we find the lowest exponent to our variables. So in the coefficients 8, 4, and 4, our highest common multiple is 4. And for y to the power of 5, y cubed, and y to the power of 4, our lowest is 3. So now we basically just divide 4y cubed from everything that we had originally. So 8y to the power of 5 divided by 4y cubed is 2y squared plus, these cancel basically. So negative 4y to the power of 4 divided by 4y cubed is minus y. So we get 4y cubed, 2y squared minus y as our final answer.
X squared minus 36. Okay, we are going to turn these into...
Wait, 1 second. Your writing is so tiny. I can't read it.
X
That's perfect.
minus 36. Great, now it looks messy. Okay, so we are going to do x squared minus 36 and turn them into a difference of squares. So, you isolate each one into brackets. 6 squared. And instead of x squared, you just put x in the brackets and you put the squared on the outside of the bracket. Due to, this is what will get us the difference of squares. And 36 divided by, or 6 times 6 is 36. And that's why we are squaring it. And so then you get x minus 6, x plus 6. So you get one negative and one positive.
So, since keyword in the factoring that Tara just did, she called it a difference of squares, not a sum of squares. So, if we had x squared plus 36x, we couldn't factor it the way, just 36. We could not factor it the way that Tara just did because it's not a difference of squares, it is a sum of squares. Now, to do a little bit of a review, if we're factoring a trinomial, which graphically is a quadratic parabola, let's say we had something like x squared plus x minus 72. So here, a is equal to 1. This is essentially a, this is b, and this term itself is c. So in this, we break apart the middle term, or no, we don't need to break apart the middle term because we already know that a is equal to 1. So what we need to find is what adds to our middle coefficient b, so what adds to 1 and multiplies to negative 72. So to do that, we could look for multiples of 72, 1 and 36, 2 and 36, 4 and 18, 8 and 9. Oh, 8 and 9 would work because 8, negative 8 times 9 is negative 72, and negative 8 plus 9 is 1 because 9 minus 8 is 1. So our numbers would be negative 8 and 9. So we pull this apart to x minus 8, brackets, x plus 9. And that's our final answer.
So now we're going to do the question 2x squared plus 2x minus 40. Since 2 is common in all the coefficients, we can take it out to make this question simpler. And then we are going to factor. So since we want to find what adds to this, which x, there's a 1 in front of it, so you find what adds to 1 and what multiplies to this number, which is negative 20. So the numbers would be, you could do a list like 1 and 20, that doesn't work, but the numbers are 5 and negative 4. And because 5 minus 4 is 1, and 5 times a negative 4 is negative 20. So then you take the 2 out, or keep the 2 out, and you get x plus 5, x minus 4.
Okay, so to factor a trinomial where there aren't common multiples in our coefficients, and a is not equal to 1, so if we had 4x squared plus 11x plus 6, first we multiply a times c, which gives us 24, and our middle term is 11. So we're finding what adds to 11 and multiplies to 24. So we do that. If we can't think right away of what the numbers are, we can make a list, like 1 and 24, 2 and 12, 4 and 6, and, oh, we're missing 3, so 3 times 8. 3 and 8 would give us our numbers, because 3 times 8 is equal to 24, and 3 plus 8 is equal to 11. So how we do that is we bring this down still, plus 8x plus 3x plus 6. Bracket, 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 bracket. This is called pulling the middle term apart. So now, from the first question we did in factoring, we know how to do this. We can pull out what is common. So 4x is common here, so we end up with x plus 2. 3 is common here, so we end up with x plus 2. Now, if these two are not the same, then you've done something wrong or your question is infactorable. But since they are the same, we're going to factor out x plus 2 out of the equation to give us x plus 2 and 4x plus 3. And that's our final answer. But if we wanted to find out what x equaled, we would take this. So we find what equals 0 in each term. So negative 2 plus 2 would equal 0. So that's x in this term. And with this one, it'll be fractional. So divide by 4 to isolate x. So negative 3 over 4 plus 3 over 4 would equal 0. So negative 3 over 4 is what x equals there.